All right. Hey, everybody. Looks like we got enough people popped in. We'll go ahead and get started. My name is Troy Daniels. I'm the technical trainer here at SimpliPhi Power. Just a few kind of housekeeping items. First and foremost, if you have any questions during the presentation, just go ahead and type it into the Q&A section. If you go up to that bar there, you can actually hit Q&A. Don't hit the raise your hand button. It won't do anything. So just go ahead and type any questions in the Q&A, and at the end we'll go over those questions. Some other items. Check out our webpage. We've got a lot of trainings heading into the end of the year. Please feel free to sign up for those. We got some exciting stuff coming up before we close out 2020 here. All right, with that, so today we're going to be doing the SimpliPhi Elite IQ Installer Training, Charge, Discharge, and State of Charge. This training is really geared around understanding state of charge, the limits of the battery, both on the charge and discharge side, as well as general just behavior of the battery. We're going to start out just going over a little bit kind of basics of our company as a whole. If you're interested in kind of getting a rundown of the company overview, definitely check out one of our Battery 101s coming up. I think there's one in December that is a good start to our company to really understand what we do. But this is a quick overview that we'll go over just to kind of refresh for any of those that might not know. So SimpliPhi Power, really what we try to do here is safe, proven, and simple technology. Safe as it's non-toxic, non-hazardous, cobalt-free chemistry. So that means there's no risk of thermal runaway. And we are UL certified 1642 on cell level, 1973 on a battery level, 9548 on a system level. UN DOT certified as well, 3480 and 38.3. If you're in California, we're actually SGIP approved. Which can be a huge benefit for customers in California looking to save some money. We are very self-conscious. We are very conscious, I should say, of our supply chain, making sure that we know exactly where these resources are coming from, no child labor involved, and try to be as sustainable as possible from what we're actually putting into our batteries. Proven technology, over a decade of experience and growth in this industry and building out batteries. We're deployed in over 40 countries and over 100 megawatt hours installed worldwide. We've been tested and validated by the US Army and Marine Corps. We actually even have special permission by the FAA to fly our batteries. They're that safe. And we are manufactured in the United States. So that's pretty rare these days. A lot of companies are white labeling batteries. We are manufacturing in the States. Simple. We try to keep our batteries and our products, for that matter, simple as possible. Try to make sure that you can utilize any generation source, whether that's grid, solar, wind, generator, on or off the grid, and really try to take advantage of our batteries as easily as possible. Okay, so again, we are a safe chemistry compared to other lithium batteries that you might see. We use lithium iron phosphate with a cylindrical form factor. That is kind of the building block of our batteries. Okay, this is a map. I already mentioned this, 100 megawatt hours installed since 2012. This kind of gives you an idea of where most of the deployments are and distribution network. All right, as far as a very, very quick overview of products, our 3.8 is biggest seller. This is our standard PHI 3.8. Comes in 24 or 48 volts, so 151 amp hours at 24 volts, and 75 amp hours at 48 volts. These are parallel connections only, so you're always paralleling these, whether it's 24 or 48. They're modular and scalable. There's actually no limit to how many you can put into parallel. Great for drop-in lead acid replacements. And that was kind of the original design. However, the use cases are numerous now. Integrated battery management system built into each of these batteries, and a circuit breaker for protection and ease of installation. We have some smaller products. Our 12-volt line, actually the 1.4 comes in 12 and 24 volts, 115 amp hours at 12 volts, 57 amp hours at 24 volts. These are smaller batteries, scalable, small and lightweight, about 33 pounds. They're great for mobile applications. They typically are compatible with most of these standard charge controllers and inverters that we would use in our other products. So for the most part, they're very compatible with what you might be used to if you install our larger batteries. They do have an integrated battery management system, and they come with an Anderson connector or bare wire. So there is actually no battery leads, you can see, which makes it a little bit safer if you are doing something like a mobile application, as well as a few other applications this battery fits well into. Okay, moving on. Expeditionary products are small emergency power and portable power packs, the little Jenny and the big Jenny. These are just all-in-one inverter charger. You can even get a little solar panel emergency kit with it. Still utilizing lithium iron phosphate, and still utilizing the same manufacturing process from us. So we really try to stick to the standards here. But these are kind of little just portable power packs. See these used a lot in emergency power as well. All-in-one, we have a few different options. We have the Express unit. This is an all-in-one unit that's designed to be plug and play a little bit more. So you do not actually need to hardwire into a loads panel with this unit. It's NEMA 3R, so it's actually outdoor rated. It has a DC quick connect inlet here that can charge from the solar array. So you can actually connect and disconnect a solar array. It has an AC inlet for charging from the grid direct. It has 4 outlets on the side as well as 2 USB ports so that you can actually pull power directly off the unit without hardwiring into any sort of electrical in the home. So they could charge it up, put it in the garage, and when the power goes out, the customer can roll it out and start plugging things into this unit directly. On the other hand is our access unit. This is designed to be hardwired to a panel, whether it's a critical loads panel, or maybe you're looking to even, utilize it for an off-grid system or something like that. It's battery, inverter, charger, all built into one. Comes in 2 different options, the Solarc or the Schneider, just which inverter is being used inside the unit. It can be DC or AC coupled. It is NEMA 3R, so it's outdoor rated. Great for existing PV arrays if you just want to add a battery in. And again, it's pre-programmed and pre-wired for the most part, so a little bit easier on installation. Okay, last 2, and then we'll get to the kind of bulk of the presentation here regarding the topic. But high voltage solutions, these are for C&I projects, mostly commercial industrial stuff. Microgrids, great example of what I see these used for. Large scale backup, so maybe you have 40-volt 3-phase on the AC side. You're going to need a large inverter. This would typically pair with those inverters. So this battery can be scaled from 200 to 800 VDC nominal on the stacks, and then those stacks can be parallel to build up an energy storage, total capacity. The BMS is an external BMS, has CAN bus, Modbus, and Ethernet connections ready to go, as well as it is actually has its own monitoring platform built directly into the battery. And very last, we have make sure here, let's see a few questions coming in. Okay, awesome. We have our newest battery, the SimpliPhi battery. So this battery, still a 3.8 kilowatt hour battery. The big difference with this battery is it has closed loop communication. So this battery is built to communicate with the inverter. Currently that's with the Solarc inverter. We're about to add some more onto that list shortly here, but it can do things like auto-populate set points, provide high-level protection. It can actually read the state of charge, voltage, charge and discharge. We'll actually talk about the SimpliPhi a little bit during this presentation as it relates to these kind of things. But this battery can actually report its own readings to give the inverter really high-level accurate readings. as well as it can actually be sized a little bit more flexible than our standard battery, as it tells the inverter how much to discharge. Okay, let's jump right into the presentation now. So we're going to start with charging. We're going to go through charging. We'll talk about current and voltage, and then we'll go into discharging and do the same thing. So as far as our standard battery goes, actually really all of our batteries at this point are rated for C/2. And C/2 relates to charging as well as discharging. But right now we're just going to talk about the charging aspect of it. So what does that mean for max charge of the batteries? Let's look at a few different batteries here. We have our 48 volt 3.8. This is our standard PHI version, 37.5 amps DC at 48 volts. So that is the 37.5 amps DC per battery is the max you can charge per battery. So if you've got a bank of 3, multiply that number by 3. 24 volt, 45 amps DC is currently how much? That will be changing here shortly, I believe, but that is a little bit less than C/2, so keep that in mind. So the 24 volts are definitely designed not to be used as strongly as the 48 volts. The 1.4, about 28.5 amps DC per 24 volt, and 40 amps DC per 12 volt battery of that 1.4 kilowatt hour model. The amplify is the same as the 48 volt, 37.5. However, just note the amplify does all of the settings through the BMS. It can auto-populate settings. So if it's plugged into an inverter that it communicates with, it will automatically tell it what its max charge rate is. So this value becomes a little bit less important for you to know. It is important to know if it's going to limit your PV output, but just know that the battery actually tells the charger at that point what to max charge. It's important to keep in mind this max charge rate when you have multiple charging sources running at once. There is something called global charge. I see on a lot of new systems where it can say, hey, you've got a generator and a PV system and the grid. Make sure that the limit is a global limit. So if you set the limit for 37.5, it will make sure that the entire system will never exceed that, no matter what's running. Now, it makes sense logically. Your generator typically isn't going to be running the same time as your PV, but it's something to keep in mind if you've got an older system, for sure. The battery protection limitations is important to note. While our BMS does have some protection built into it on the standard 5 batteries, so these 4 models we're looking at here, it does not prevent damage if you overcharge the battery too many times. So the amplify, on the other hand, really has the ability to tell these inverters and these chargers it communicates with not to overcharge the battery. So that protection's built in. It's a bit more dummy proof, whereas the standard 5 battery, really you need to program and keep these values in mind when you are programming a charger. Okay, so let's talk about that. Let's talk about programming. So limiting the charge rate on various devices is fairly straightforward. Charge controller, really easy to use. You just set the limit. That's it. It's, you know, I see a question I want to go ahead and just answer. How did you arrive at these amps DC charge currents? Well, let's take a look. 3.8 kilowatt hour battery. We know the max charge rate is C/2. That's just what the battery can handle. That's how we arrived at it. So C/2 for a 3.8 is 1.9 kilowatts. If we were to talk in kilowatts, and then you just convert from there. So I would do 51.2 as the nominal capacity of the battery. So that would give you this value here. I think it's actually even a little bit off. I believe they are using 52.1. Yeah. So just note, this is just converted from kilowatts at C/2 into amps DC. All right, back to it. So again, charging, you want to limit your charger. Charge controllers, just set that limit. Super easy. Calculate how many batteries you have. Look at your charge limit. It's in all of our manuals, all of our spec sheets, all of our integration guides, has that value written out in really plain, hey, it's this value. And if it's a specific inverter that we have an integration guide for, it'll tell you exactly what they're going to ask the value to be in, whether it's kilowatts, whether it's amps, whether it's a percentage. The inverter charger is ideally the exact same thing, other than AC coupling, which we'll get to in a second. But if you're just charging from the grid through an inverter charger or through a generator, you know, it's pretty easy. Same thing, just set it for whatever the max charge is. Again, the SimpliPhi battery does all of this automatically and auto-populates these set points for you. The AC coupled systems are a little different. So if you've got an existing array with an AC coupled, a grid tied array that you're adding a battery system to, you need to keep in mind that you can't just set the limit. You need to follow guidelines for sizing. So I would just say there's inverter guidelines, there's code guidelines, and then there's our guidelines. Look in our manual. If you're AC coupling, just see. So basically keep in mind that let's say you have 3 SimpliPhi batteries, these 3.8 models. So we know we can charge at 1.9 kilowatts per battery, which again is just this number converted. So that's 5.7 total. So if you're AC coupling to 3 batteries, make sure that you are only using 5.7 kilowatts AC coupled. AC coupling is not rockets. I mean, it's not a foolproof science at this point. And while the system should curtail if there was more PV than the batteries can handle, it often doesn't. So our guidelines are just follow the C/2 rate. So just take the max charge rate and make sure your PV matches up to that. And keep in mind how old your grid tied inverters are, because that will affect how well it curtails as well. If you want to know more about that kind of situation, by the way, I've got a great webinar on AC and DC coupling that goes way more in depth about sizing, understanding how it works, and really kind of what the differences are. So I'd encourage you to check out that recording on our YouTube channel if you are interested more in that. Okay, a little bit about voltage and charging. Voltage wise, so absorb bulk is, actually let's say, okay, so we're gonna start with charge controllers. So if we were using a charge controller, we're DC coupled, we're gonna use absorb and bulk, of course. That's 56 volts DC at 6 minutes. And for the most part, that's the bulk, as much of a planned word as it is, that's the bulk of the charge when it comes to lithium batteries. That's about 90% of the charge happens there in that stage. So we don't always need float, but when it comes to a charge controller, if you're charging from like a PV array, go for it. Use a float voltage. 54.0 is where we recommend it. I'm just going to speak in 48 volt terms, by the way. You can always divide if you need 12 or 24. But float charge is totally okay when it comes to DC coupled, and you're maybe a grid tie or a solar array or something like that. Now, if it's an inverter charger, you can set it a little bit lower. This is kind of changing right now. So you can charge at 54.4 volts on the absorb and the bulk at 1 hour instead of the, 6 minutes that we were doing here. That's really low. But I would actually say our manuals are going to be updated soon. We're just going to say 56 volts at 6 minutes, regardless of the charging source. Is just going to be the standard from now on. This 54.4 at 1 hour, I would say the only reason you should ever use that is if you've got an older charge controller or charger that does not go down to 6 minutes on the absorb time. Now, when we are grid charging or charging from an AC source such as generator, or even an AC coupled array, we need to make sure that we do not use float. Doesn't make a lot of sense in that case. definitely doesn't make a lot of sense when we are AC coupled. So this is a 2-stage no float charge when it comes to charging from an AC source. As far as compatibility with inverters and chargers, make sure you're checking them for, if it's an older model, like I mentioned, check for this absorb time. Make sure they warranty for lithium batteries if it is an older model as well. Something I'll touch on very briefly, external chargers. If this means basically, you'll see something called approved chargers on our website. This is just referring to if you're using like a wall plug-in charger. So this could be something like a bike charger, a battery charger, they call them sometimes. If you're looking for one of those to maybe start up the battery, maybe you've over-discharged your battery or something, just let us know. We've got a list of approved ones that work. And then back to BMS shutdown and protections. So the battery management system, actually, we'll save that for later. We'll talk about that coming up here. But just keep in mind, again, with these protections, the PHI battery, the standard SimpliPhi battery, still needs to really be intuitive when it comes to programming, as the BMS is not going to be an end-all to save your battery if you misprogram or don't size right or just don't install correctly. The Amplify battery is a little bit more forgiving as it does most of the work for you, but definitely still, you should always be, on the ball with reading these manuals and integration guides. Okay, we're gonna go into discharge real quick. And then we're gonna end with state of charge. So discharge, we'll go through pretty quickly here. This is a nice discharge curve here. I'm gonna say this is at C/2, and we're kind of refining this right now, but you can see the battery starts charging pretty high and then goes into a state of rest, which we'll talk about. And then it's pretty flat as it discharged. And again, we'll go into SOC, state of charge here coming up. Okay, C/2 for discharge. So again, C/2 relates to charge and it relates to discharge in this case. Though in this case of discharge, we're really talking about continuous discharge and not max discharge. So not what I would call surge. We're just talking about what's the continuous discharge. So mostly relative to the inverters, max continuous. So again, it's the same value as we saw before. These are the exact same. This has C/2. Again, the Amplify battery does all the work for you. It programs the inverter and says, don't over discharge me. So if it's hooked up to the solar, currently that's the inverter we're pairing it with. Even if you put one battery on a 12 kilowatt hour inverter, it'll say, hey, don't ever over discharge me. And it'll set that limit automatically. Inverters, when you're using our standard batteries, do not have the ability to limit the discharge oftentimes. Most inverters don't. So keep that in mind that we would require sizing to make sure that you do not over discharge. So the battery should be twice the inverter's continuous output. So if you've got an 8 kilowatt inverter, you should have 14 kilowatt hours of batteries minimum. If you want to know more about that sizing and requirements, check out my BAT 101 or go onto our website and check out our sizing calculators that go over this as well really well. But again, the Amplify will actually make sure that it programs the inverter not to do this. So you don't really have to worry about sizing so much. Okay, surge rating is a little different. So it's actually 60 amps for each battery, but at different voltages. So it's actually a little bit lower per battery. So 60 amps at 10 minutes for a 48 volt, and then 60 amps at 10 minutes for a 24. So it is a little bit lower for the 24 and the 12 volts. So just keep that in mind. The 48 volts are really what you want to use if you're trying to cover things like air conditioners, well pumps. Use that bigger 48 volt. We are upgrading the 24 volt, I believe, soon, but right now it does have that lower discharge. The new Amplify actually has an even higher discharge. It can do 100 amps at 10 minutes at 48 volts per battery. So just to give you an idea of what that is, that would be 5.1 kilowatts for 10 minutes per battery. So if you've got a bank of 4, it can do about 20 kilowatts for 10 minutes. Actually a little over. So it can definitely handle quite a bit of surge. Now, as far as C/2 goes and residential use, keep in mind that you really aren't going to be using the limit. These limits especially, sorry, let me go back. These limits are rarely going to be touched if you're sizing correctly for most use cases. So most people don't come to you with an off-grid system and say, hey, I want 2 hours of battery life. So you really should be sizing larger either way. It shouldn't matter. Grid tied, maybe you might have a customer ask you for a 2-hour discharge battery, but most of the time they're going to be wanting more time of discharge than C/2. So those limits shouldn't really be a problem in a real world application if you are sizing correctly. So we'll talk about breakers here. It's not a surefire way. I would never recommend if you do have, so let's say you do have an inverter that's a little bit larger than the battery bank can handle. I've seen some installers put a breaker in place. I would be careful with that, but it never hurts. So if you've got, let's say 3.8 kilowatt hour battery at 48 volts, and you've got 2 of those, you know your max discharge is 37.5 amps per battery. So the 2 of those can handle 75 amps DC. Max continuous discharge is the entire bank. So you'd probably go down a little bit to a 60 amp breaker. And let's say your inverter could output more than the batteries can handle. This might help protect the battery from over discharge. But again, just sizing correctly would be the sure-proof way of not over discharging. There's some other functions in inverters that can help with over discharge, like grid support or generator. Actually, sorry, grid support's a bit of a different function, but load support, I should say, or generator supports, basically saying, you know, hey, I can only discharge this much out of the batteries, turn on the grid or the generator when the load exceeds that amount. Now, this is reliant that the generator is gassed up or that the grid is present. So again, not short-proof. If you just follow our sizing guides, you should never have an over discharge event. So it's as easy as that. Okay, and very last, let's talk about what I like to call the knee on discharge. So you can see here, it's very, I talked about our curve earlier, it's very flat, but when it gets to this point right here at about, I would say about 20%, it starts to drop a little faster and then actually pick up exponentially and start really dropping off until it just tanks. This is what I like to call the knee. It's pretty common in lithium batteries. It's something to consider when there's a few factors to consider here. So load affects this. So C/2 load is going to make this more drastic and make the battery voltage drop very quickly if you have a heavier load on the battery than a typical residential load. Now, low battery cutout is a function in an inverter that can actually put the inverter into standby so that you do not require to actually manually reset the system or reset the batteries. This knee, and if you've got a heavy load on this, on the system, you could possibly trigger the low battery cutout in the battery before you trigger it in the inverter. This would cause the installer to have to go out and actually manually reset the batteries. So we want to try to avoid that. What we can do to avoid that, set your rebulk or your recharge a little bit higher. Make sure you're charging if there's solar, if there's generator, if there's grid. Charge up that battery. Don't let it get to that low, that 10% state of charge if you do have a heavy load on there. Low battery cutout, you can always set a little higher. I like my low battery cutout at 50.2. This is 80% depth of discharge or 20% state of charge. This is a great voltage to use. Again, if you're using 24 volt, 12 volt, just divide that number. But again, this knee doesn't typically come into effect for most residential systems, but I have seen a few cases where industrial stuff where they're using a really heavy load on the battery that's continuous, and they will note that their battery drops pretty fast, and they maybe need to take their low battery cutout, delay, and lower it so that the inverter goes into a state of disconnect before the battery has the ability to go into disconnect. Once the battery's gone into disconnect, it requires a manual reset. So it's not very fun, especially if the site's far. Okay. Been flying through these. Let's get through the very last few, and then I see a lot of questions here, so we'll get to everyone's questions. A little bit about state of charge. Okay, let's just talk about this graph, or this on the right here, this little table here. These are levels typically at C/2. This is what the state of charge relates to as far as voltage. This is just an estimate. Now, I will say this is done by our engineering team in a controlled environment. I'm going to tell you right now, I see much different in the real world versus what's controlled on the testing. For instance, 52.5 or higher is 100% state of charge. This is resting state of charge, which we're going to talk about in a second here. I don't see it that low. I see it typically in the field about 53, 53.3. 48.0 is 0% state of charge, I can say almost without a doubt. And then these are fairly accurate. But just really kind of consider, if you're looking at a chart like this, you know, it can vary a lot in the field. So these are just typical at a controlled environment at C/2. So what is resting state of charge? I define it, maybe some people might argue with the way I define it, but the way I define it is that the battery is no longer in a state of charge. So no charge controller or inverter charger is currently charging that battery. There at least needs to be a small load connected, or else the battery might hold that high voltage that it's sat at. So to go back, we talked about charging the battery at 56 volts, but 100% resting state of charge is about 53 volts. So 53 volts, the battery drops significantly. Let me go back real quick. Sorry about that. I just want to show you this. So again, we charge really high, and then the battery settles and it goes into a resting state of charge. This is completely normal and still correlates the battery with 100% state of charge. So that is kind of resting state of charge. And it's important to understand, and often can be important to explain to a customer that might say, hey, the second my battery comes off that charger, it loses like 3 volts. Well, that's completely normal. It's just we charge really high and then we let it settle. Battery monitoring wise and SOC-based inverters. Let's skip the SOC-based inverter stuff because we're kind of working through that. That would be something like a Sunny Island is an SOC-based inverter, which really requires communication. So that's where the SimpliPhi is going to come in. But as far as battery monitors go, they're not super accurate, a lot of them still, for lithium batteries. I would say the vast majority are definitely still sized for, manufactured with lead acid in mind. So you often are going to not have the most accurate readings from battery monitors. I always make the suggestion, a little free advertisement for them every time, but I recommend the Victron BMV if you want a very, very, very highly accurate battery monitor. So the Victron BMV is, from what I've seen, the BMV 700, I believe, or 720, I think there's 2 models, is the most accurate I've seen for lithium iron phosphate batteries. Now, the more accurate, or the most accurate way to measure state of charge and to have a customer or an installer read that off of a meter is to use our amplifier battery, our new closed-loop communication battery. So if you're using that with an inverter that pairs with, the battery is actually what's reporting state of charge direct to the inverter. So that is the most accurate reading you could possibly have. But again, battery monitors are still pretty tricky when it comes to lithium batteries. So why would you want to know state of charge? Why would you want to know any of this, really? I consider it to be a useful tool when it comes to advanced programming and what your customer wants or the mode of operation. So you might know that your rebulk or recharge has some room to play around with. And maybe, you want to set that at 51.7 because you've got a customer that says, hey, I just want to use the battery for backup only. I want to make sure that it's nice and charged going into the night. And then as the installer, knowing these correlations and definitely knowing the real world correlation of what you see in the field, you can say, oh, well, that's great, customer. I want to set this. I'm going to set your rebulk a little higher so the battery doesn't drop so drastically before the grid goes out. And you're not stuck with a 50% state of charge battery in this grid outage. It can also help with generator and grid set points. So, avoiding excessive generator running, understanding how low you can set your generator or your grid to start charging, and even avoiding the knee we talked about earlier. Another big one we see these correlations used for is cell voltage. Understanding where the battery is 100% helps us set that cell voltage in a way that only sells off PV. Settings can be a little different from inverter to inverter company, but still knowing this correlation can really help when it comes to making sure your customer is not losing that extra excess cell, but maintaining that their battery is nice and charged. Okay, one more thing before we hop into Q&A. Just FYI, I know this question is going to come up before the Q&A. These slides will be available, just FYI. So just keep that in mind that they will send out a recording as well as the slides after the presentation at some point, probably sometime at the end of the week. I want to talk very briefly before we end about our IQ installer qualification program. This is our not a requirement to install our batteries. It's an added benefit if you already are installing our batteries. So let's jump right into that. Let's go to the website real quick. Maybe if it lets me. It's thinking. Man, well, it doesn't want me to today. Let's see if we can anyway. How about that? Okay, so just a little bit about our installer qualification program. If you're looking for it, it's under training. It's right here. If you are an installer that's already installed 2 of our batteries, you've attended this training, the AC coupling training, and the IQ the IQ battery 101 training, go ahead and fill this application out and it'll send it over to me. I'll send you the info for the last few steps you have to take. But if you become one of our IQ installers, you not only get a bunch of swag from us, you also, biggest benefit here, you end up on our where to buy page. So you can see we've got IQ installers all over the place already. So that, for instance, Bright Future here, they're an IQ installer. They land on this page. We have a lot of customers that come through our website looking for batteries to be installed. While we don't mind sending people to distributors and let them decide who's the best one to pass these leads off to, we'd much rather that they stumble across an installer company on our website that's in their area and they go ahead and just reach out direct, and we hopefully drive you some business. And we know that you can install our batteries as you've gone through this process. Look at why he's got a lot of them. And it really tries to benefit the installer to grow their business directly through us. So if you're already installing our batteries, check out that program. Again, it's under support. Go to IQ Installer Qualification Program. Scroll down and here's the application. Takes about 15 minutes and we can get you all certified. Send you out a swag pack, get you on the website, and you'll see some more added benefits coming as we highlight our IQ installers more and more this year. Okay, let's go ahead and pop into the Q&A real quick. If you have any questions that you did not type in yet, go ahead and type them in now, and I will try to get through them right now. Can the BESS cabinet be AC coupled with existing commercial solar 300 kilowatts needing 400 kilowatt hour BESS? I'm not sure what you're talking about with the BESS. Maybe if you want to elaborate in there with the chat. What DC coupled inverter do you recommend for larger commercial off-grid systems? So something like 100 or 200 kilowatts to 1 gigawatt. We would never recommend going 1 gigawatt with our batteries, first of all. It's a little too big for what we do, but Dynapower is a really good one we pair a lot with the high voltage stuff. Can 40 volt three-phase solution be DC coupled? Yeah, sure. I mean, 40 volt three-phase just has to do with the AC side, so not really anything to do with the PV side, the DC coupled side. Can we support 40-volt three-phase containerized solution off-grid? Yes, absolutely. So slides for reference, already answered that one. Copy of the presentation. I knew that one come up. Always does. But yes, we will send out that presentation. I see a hand raised. I cannot unmute you, so just type it in the Q&A, please. Okay. The graphs are interesting. However, you go over the page really quickly. Well, I apologize for that. If you have any questions, just shoot them over now. Happy to go over them. Oh, the graphs. Yeah, I go over those graphs a little quick because I'm actually revising those graphs. Sorry, I got the question now. I'm actually revising those graphs currently. So I don't want to show them too much as we're about to publish new ones. But stand by. I'm working on that right now, actually. How do you perform a manual reset of the batteries? Great question. So in like a low battery cutout situation, you would actually need to reset the breaker on the battery, and that would reset the battery management system. Okay. So back to this BESS. Can the battery energy storage system cabinet be AC coupled with existing commercial solar? Yeah, absolutely. Just it depends on the inverter. But yeah, you need to make sure that if you've got 300 kilowatts of PV, your battery needs to be 600 kilowatt hours as far as the sizing goes. But yes, you can AC couple. Okay, let's take a look. Okay, that's a good question. Please, from your perspective, what are the key parameters to consider when selecting a lithium battery and lithium ion in general when comparing your batteries to others? Price, and I don't mean price up front, I mean cost of ownership. So look at our LCOE calculator on our website. It's basically ROI for batteries. What is the cost of ownership? How long is that battery going to last? What's the cycle life's warranty? What's the efficiency? What's the maximum discharge, maximum charge and discharge? How long has that battery been around? And above all, when you're comparing our battery to others, safety, looking especially when you're comparing to cobalt-based lithium batteries such as your Powerwall or your LG Chem. Thank you very much, Nancy. Oh, there we go. What is the rebulk recharge? And is that function that is available on the SMA Sunny Island? Rebulk recharge is just where the inverter charger or the charge controller will initiate a charge cycle. Yes, it is definitely available on the Sunny Island. Not sure exactly what it's called in the SI, but check out our integration guide or email me. I'll send you our integration guide for the SMA since it's not live currently. And it should have that set point, whatever it's labeled in the SI. Using the Schneider charge controller, what are the charging parameters? I'm not going to go over all of them live. There's quite a bit of them, but go to support, go to integration guides, pull up Schneider integration guides. Here's our Schneider integration guide. Go to charge controller settings. And look at that. We got all the inverter settings, all the charge controller settings laid out in this manual. So just check that out if you're interested. What is your preferred pairing for 208 three-phase inverters in the 30 kilowatt range? Well, I probably shouldn't say specifics, but I personally like, from days of installing, the Schneider XW Pro for three-phase stacked in threes, or the Solarc stacked in threes. Now the Solarc is kind of cool because it can do 2 legs of three-phase with a single 12 kW inverter. It just can't do true three-phase. But you can always stack 3 of those. So those would be my suggestions. Would be either the Schneider or the Solarc. Best email for me, good question. Let me just get back to this page so it's here. Just go ahead and email me at training@simplifypower.com. Could you go over the calculation of max charge current? Yeah, so I see you're getting a little bit of a Well, actually, so again, you're using 48 volts there. First and foremost, let me just say this. So the question is, this gentleman used 3,800, which is the watt hour capacity, divided by 2 for C over 2, and you get 1.9 kilowatts or 1,900 watts, excuse me, and then you divide it by 48. So first and foremost, you want to divide by 51.2, which is the actual nominal voltage of our batteries, and you'll get 37.1, just FYI. The 3.8 is actually a little bit lower than our true capacity, is just a little bit higher than 3.8 exact. So, but I promise you 37.5 is the exact maximum continuous discharge. It's just a setting, right? It's just a spec. So look at the spec sheet if you ever need it. You don't need to do the calculations. It's actually spelled out back to here. So if we go to our product documentations and we're at our 3.8 kilowatt hour battery, look at that. It actually has it listed somewhere. Oh, I hope I don't eat my words here. Okay, right there. So 37.5 amps DC per battery. It says it both in kilowatts and in AC or DC amps. So it is there. What voltage to set the 80% DOD cutoff? 50.2 is where 80% DOD is. Solutions for cold weather or off-grid applications. Cold weather-wise, so temperature range is 32 to 120. If you've got lower than 32 degrees Fahrenheit, we do have some hot start solutions where we have a heating pad option for our access units, as well as the SimpliPhi battery actually has an internal thermostat that can disconnect the battery if it gets too cold. Are there any inverters that you do not pair well with? Your battery should be avoided in general pairing with? Good question. I mean, probably not really specifically at this point. These are the main ones I see them paired with, or what's listed here. If you've got an inverter that's not on our integration guide page, I would just recommend reaching out and asking real quick. Never can hurt. So just look through that, and if you can't find your integration guide, it's never a bad idea. If the battery system stops due to low battery cutoff and we turn off the batteries, is there amount of time to leave the batteries off before turning back on? So if the inverter goes into low battery cutoff, don't worry about it. It will charge itself back up and go into standby. If the batteries internally go into cutoff, I would at least give it like 5 minutes with the batteries off to reset the BMS, the battery management system. Yes, I see a comment about the integration guide still using the 54 volts DC. As I mentioned, I am still upgrading some of our, it's not going to hurt. Let me just say, whatever's in our integration guides, even if it's being updated right now, which it is, the old settings are never going to be something that's going to harm the battery, but sometimes we just update things to make it a little more simple, or that we've just refined testing. But if your battery's working fine, I wouldn't worry too much. Do you have a solar battery system for a bug out? It depends. Yeah, I mean, like the Express unit's not a bad idea. This is that little one here that you see, because that is all in one. I mean, the cool thing with our batteries themselves are they're mobile. They can actually be mobile. So you could easily build out something that is mobile. And our batteries are designed to be small little building blocks that you could customize however you want. So you don't even need to go with one of our energy storage solutions. You could just go batteries and build out however you want. Highest operating temperature, good question. I don't know off the top of my head. It is, so this is not charging, this is operating, is 140 degrees Fahrenheit or 60 degrees Celsius. Highest charging temperature is 120 degrees Fahrenheit or 49 degrees C. SMA and outback inverters work nice with the new SimpliPhi batteries. So the If you're talking about the AmpliPhi, currently we're only paired with the SolarArc right now with those batteries, but soon we will have SMA on that list as well. Outback, I would just pair with our standard batteries. And SMA with our standard batteries is actually kind of tricky. So I'd wait till I'd use the AmpliPhi with the SMA Sunny Islands. So yeah, to your question again, the SMA inverter, I would say don't pair it with the standard battery. You want to look into the because it's really tricky to use with the standard battery. That's why we pulled the integration guide. I would definitely just use the AmpliPhi, the new battery. It's a lot. It's gonna communicate with the inverter a lot better once we have that all set up. What is the effect of over temperature on the battery? So if it was to go above 120, you could damage the battery. Now, I'll say, for instance, between 32 and 120, you're not going to see a ton of efficiency loss like you would with the lead acid. So definitely, you don't need to stick at 75C or anything like that to get really high efficiency out of the battery. All right, perfect timing. I just want to thank everyone that did show up, tune in and listen. If you have any questions, again, just shoot me an email here. This presentation is NAPCEP approved for some CEUs. So if you need CEUs, shoot me an email at training@simpliphipower.com. Just tell me your full name if it's not already in your email or something, and just say, hey, I need CEUs. I'll shoot you back a certificate to send over to NAPCEP. So again, if you need CEUs, this is worth half an hour of CEUs. So just shoot me an email at training@simpliphipower.com. And I will go ahead and send you over those credits, or the at least a certificate to send for credits. So thanks, everyone. Really appreciate it, and have a good day.